This is part 1 of the simulation that we are going to cover for designing for Industry 4.0. The agenda for today, we're going to do a recap on Industry 4.0, discuss some product design challenges, what is simulation, digital prototyping, Autodesk Nastran, additional benefits, a practical example, and then I'm going to open up for some questions. First, I would like you to please share, comment, like, and subscribe to our YouTube page and all of our digital platforms. You can find on YouTube all of our previous webinars, as well as this one if you would like to just recap on some things. It might be of benefit for you to just subscribe to that. So hi, I'm Melanie Burger, Manufacturing and Process Plant Specialist. I have a mechanical engineering diploma and over 10 years experience in a drawing office as a supervisor. I'm very passionate about data management as well as training, and I'm an amateur bass and drums player. Before we start off, I would like to hear from you. Let me just open up the poll questions. I would like to know how familiar you are with Baker Bains and all that we offer. Very familiar, somewhat familiar, or not familiar at all. I'm going to give about a minute for you to answer. Okay, so I see that most of you are somewhat familiar, and then secondly, there are some of you that's not familiar at all. So I'm just quickly going to run through what it is that Baker Bains does. So Baker Bains has evolved over the past 6 years from being an Autodesk reseller to a consulting company. We set out to solve our customers' problems through digital transformation, and we want to help you to design and make a better world. In doing so, we offer various business process improvement consulting services, survey and design hardware and consulting, design software consulting, and we top it off with a blended learning approach to how we believe you as our customers can or should digest information. So we're going to recap quickly on the 4th Industrial Revolution. And it started with the first revolution. The first industrial revolution. So most of the industrial work was done manually or aided with animals, and the first revolution was started in the 18th century. During this, manual tasks were replaced by use of steam engines and other machines. Agriculture and textile industries benefited most from this first industrial revolution. The second industrial revolution was started with the use of steel and electricity inside factories. It started at the end of the 19th century and early days of the 20th century. During this era, factories were electrified. As a result, productivity increased and mass manufacturing concepts also came into the picture. Development of railway networks also enabled the transportation of goods from one place to another faster. The third revolution was started in the mid of the 20th century. Most of our today factories are the result of the third industrial revolution. During this time, the manufacturers started to incorporate electronics, digital technology, and automation inside the factory. And now we are living in the era of the 4th industrial revolution, or Industry 4.0 for short. In advanced factories, automated machines and robots are aiding human workforce to do manufacturing activities. But this is just a start. Industry 4.0 will take manufacturing to a new level by introducing the concept of smart factories, producing smart products, using flexible mass manufacturing technologies. Inside smart, fully automated factories, machines will operate independently. So how are we going to help you to get to Industry 4.0? We are running a campaign and we walk you through the steps that you need to get designing for the fourth industrial revolution. We had an event a few months ago where we discussed the steps that we identified to start you off with this challenge. And we started off with taking your 2D designs to 3D. And then we spent a few months discussing design automation. Now we are concentrating on the third step, which is simulation. I also want to stress the importance of good document management systems in any of these stages. We will look more deeply into Vault in upcoming events. And before I start with the next step, I just want to launch another poll for you. Very quick and easy. Please just let me know. Are you ready to start designing for Industry 4.0? Yes, no, or you are not sure. It might be that you are not sure because you don't really know what it all entails. Some of you that are part of this journey from the beginning of January with us, you might know already what it all entails and know where you stand with your designs and what you need to do. Okay, thank you very much for that. It will help us a lot in knowing how to address the issues of our customers. Right, we're going to look at some product design challenges. So you might face these challenges. For instance, when will it fail? How light can I make it? Will it overheat? So you need to make accurate design decisions without building multiple physical prototypes. You need to seek confidence in simulation results, and you require before investing resources in design changes or in new products. Product designs include a wide range of materials and not just common metals. Motion and the combination of multiple physical effects are critical design considerations. Product design teams need to perform simulation on geometry from multiple CAD software tools. Not just Inventor and not just AutoCAD, but multiple CAD software tools. You need to avoid field failures before it happens. So you can determine durability of structures under repeated loading, and you need to optimize the design and manufacturing of models. To meet the demands of an increasingly competitive global market, manufacturing firms face intense pressure to constantly innovate, reduce development cycles and time to market, and avoid in-field failures while staying profitable. There are powerful benefits that a CAD-embedded FEA technology can bring to your product development process. Advanced analysis empowers engineers to subject their designs to real-world behavior, and it optimizes product quality for performance before manufacturing. This translates into innovation, better quality, lower cost, and minimal field failure. So what is simulation? At its core, manufacturing simulation is an inexpensive, risk-free way to test anything, from simple revisions to complete redesigns, always with the purpose of meeting production goals at the lowest possible cost. Manufacturing simulation is the computer-based modeling of a real production system. Simulation allows organizations in the manufacturing industry to analyze and experiment with their processes in a virtual setting, reducing the time and cost requirements associated with physical testing. Unsurprisingly then, running a high-functioning production line can be quite a challenge. Businesses are constantly adjusting their manufacturing schedules to fulfill ambitious quality, cost, delivery, and flexible goals. The wrong move can result in major supply chain disruptions, so it's essential to have the right support. You need shorter production cycles, faster data entry times, alleviate work in process, reduced lead times, more customer satisfaction, accurate sequence planning, better quality products, fewer admin tasks, empowering leaders, and picking the right manufacturing process software. Now, Autodesk Inventor Simulation Suite software combines a simulator for motion dynamics with a powerful linear finite element stress analysis application. To understand the performance of a proposed design, a designer starts by running the dynamic simulation tool to calculate the dynamic performance. The results of the simulation represents the positions, velocities, and accelerators of the mechanism throughout its operational cycle. It also includes the reaction forces at each joint. Now, these forces are then used as the input parameters for the second phase, in which finite element stress analysis is used to compute the internal stresses in those highly loaded parts. This process is summarized in the accompanying diagram. Autodesk Inventor Simulation Suite addresses the shortcomings of traditional, dedicated FEA and motion analysis by providing easy-to-use tools that work directly with the Inventor 3D model. The resulting ease of use gives designers a true digital prototype that can be used to experiment with different design options. At the same time, it can increase confidence that the performance of the final design will meet the customer's expectations. The ability to predict and transfer reaction forces to the stress analysis environment allows designers to leverage the digital prototype to optimize part geometry while reducing the need to build costly physical prototypes. Simulation has become an essential tool that every engineer can now use. That is because when you use simulation, you can evaluate decisions as you make them, create more opportunity like improved performance and reduce the likelihood of failure. With the PDM collection, you have access to a wide range of simulation tools, including nonlinear, thermal, fatigue, vibration analysis. It's all right inside your software. Linear analysis is helpful as often included, but it is limited to static loads and a material model that is only appropriate for metal. On the other hand, nonlinear studies eliminate several limitations. They provide advanced material models specific for plastic, rubber, or foam. Choosing the appropriate material is essential to determine accurate results. Determining stress and deflection gives insight to design integrity, but does not tell the entire story. Is it possible that your design may buckle at some point as the load is applied? This can only be checked by running a linear or non-linear buckling study type. They have the power to provide you with the maximum load your design can handle before it loses its stiffness or undergoes catastrophic failure. Even animate the load to give you an understanding of the behavior of your components. And if there is an issue, changes can be made based on the results from the solution. And remember, the study types you have set up can simply be run again the moment your models have been updated, all in one interface. The tools included in the PDM collection help you to gain valuable feedback in your design decisions early in the process, giving you more opportunities to reduce cost and validate performance. Autodesk digital prototyping is an innovative way for you to explore your ideas before they're even built. It's a way for team members to collaborate across disciplines. And it's a way for individuals and companies of all sizes to get great products into market faster than ever before. from concept through design, manufacturing, marketing, and beyond. Autodesk digital prototyping streamlines the product development process from start to finish. We're going to take a look at Autodesk Nastran. You can use a wider variety of study types and materials in your analysis. Inventor Nastran delivers finite element analysis tools for engineers and analysts. Simulation covers multiple analysis types, such as linear and nonlinear stress, dynamics, and heat transfer.
Autodesk Inventor Nastran is an in-canvas Inventor toolset for performing finite element analysis using the Autodesk Inventor Nastran solver. In this video, we will introduce you to some of the powerful capabilities of Inventor Nastran. To access Inventor Nastran, click the Environments tab and select the Autodesk Inventor Nastran button. In-canvas simulation tools provide a wide range of simulation types, including statics, dynamics, nonlinear, composites, and heat transfer. Advanced meshing technology means greater accuracy for your geometrically complex models. Faster and more robust automated contact generation provides better accuracy for assemblies. Highly accurate nonlinear and dynamic capabilities and advanced material models means results you can rely on to make more informed design decisions. Inventor Nastran provides a comprehensive selection of material models. Examples include isotropic materials, including plasticity, orthotropic materials, and other advanced material types ranging from shape memory alloys to rubber. Because of the in-canvas integration with Inventor, you can make changes to the geometry model and have them automatically propagate to the finite element model, saving you time and eliminating rework. Inventor Nastran provides a powerful and convenient toolset for studying the effects of design modifications and exploring design concepts.
So Autodesk Nastran is an industry-recognized general-purpose finite element analysis solver. It's used for analyzing linear and nonlinear stress, dynamics, and heat transfer characteristics of structures and mechanical components. The solver works with Nastran compatible pre- and post-processors and offers real-time results and changes in solution parameters while solving or helping users to identify and fix issues early in the simulations. This high-end simulation technology is offered as a value-enhanced package so you can obtain accurate results for complex simulations. Autodesk Nastran is the integrated solving platform for Autodesk mechanical simulation offerings and is part of Autodesk digital prototyping solutions. It's proven and credible, accurate, scalable, and advanced. So some additional benefits. You can start with basic analysis for exploring the viability of design alternatives and concept validation, and move on to advanced analysis. If and when powerful analyst tools are needed, this can be used. Autodesk Nastran has a wide range of analysis capabilities from basic to advanced, linear and nonlinear, dynamic analysis, as well as powerful automated impact and drop testing. Several special analysis types are also available, such as fatigue, explicit FEA for high speed and extreme deformation impact, and advanced techniques for composites. So let's look at some basic analysis capabilities. You get the linear static analysis. Linear statics is one of the most common types of analysis. This determines stress, strain, and deformation resulting from applied static loads and imposed constraints. Linear stress, strain, deflection, inertial relief, thermal stress and deflection, pre-stress, mass properties, and multi-axial fatigue are all parts of the analysis that you can run. You get the buckling analysis. This assesses the stability under loads. It examines structures for sudden failure modes caused by comprehensive forces. So it's critical loads and mode shapes, linear and non-linear initial stresses that you can analyze with this buckling capability. Pre-stress, static, and normal modes. This enables engineers to analyze structures subjected to initial stress and model the effect of the initial stress state on the structure's displacements, stresses, and modes. You get normal modes. This determines the undamped natural mode shapes and frequencies of structures, allowing designers to explore and resolve problems with noise and vibration. It also analyzes natural frequencies and mode shapes, flexible and rigid body motions, modal participation factors, effective mass or weight, and reaction forces, linear and non-linear pre-stress or stiffening, and virtual fluid mass. Get the linear steady-state heat transfer analysis using the principles of conduction and convection heat transfer. Engineers can examine designs for equilibrium temperature distribution. Conduction, convection, and radiation are part of these capabilities. Composites. This provides easy, straightforward handling of complex ply data. Analysis based on latest failure indices like PUC and LAR-CO2 means reliable and insightful results, linear and nonlinear. And this also works with conduction, convection, and radiation. Get assembly modeling with contact. This goes beyond analyzing individual parts. Real-world simulation of assemblies is possible with sophisticated modeling of different kinds of contact interactions, including sliding, friction, and welded contact types. And then last but not least, thermal stress. This supports the analysis of structures subjected to thermal loads. Some advanced analysis capabilities include the following. And you might have guessed it, nonlinear static. So this computes advanced nonlinear solutions such as large displacements or rotation, large strain, plasticity, hyperelasticity, creep, and so forth. You then get nonlinear steady-state heat transfer. This solves heat transfer problems with nonlinear thermal boundary conditions, such as temperature-dependent thermal properties. You get linear and nonlinear transient response. This simulates the response of a structure through the period of time under the influence of constant or time-dependent loads, for example, impulse loading. You get random response. This might have been a small mistake. You get frequency response. You get nonlinear transient heat transfer. You get AIA and drop tests, advanced nonlinear material, and random response. So with random response, analysis of structural behavior in response to imposition of random dynamic loads can be analyzed. The frequency response determines the structural harmonic response based upon the frequency-dependent loads. Nonlinear transient heat transfer solves heat transfer problems with nonlinear linear thermal boundary conditions that vary through time, for example, power fluctuations. The automated impact analysis, AIA, and drop test. This sophisticated treatment provides realistic and meaningful impact and drop test simulations. The only inputs required are projectile velocity and acceleration. Advanced nonlinear materials are a solver that captures complex nonlinear phenomena such as plasticity, hyperelasticity, and shape memory effect. This enables analysis to model a wide range of materials, from metals and shape memory alloys to rubber and soft tissues. We're going to look at some quick examples. So engineers using Autodesk Nastran in CAD can quickly set up and solve advanced nonlinear finite element models. So in the buckling example, you can simulate the lift arm assembly that needs to be light, yet able to lift heavy objects without bending or buckling. With the nonlinear static stress analysis, you can simulate this plastic hand shield on this hedge trimmer that needs to be able to bend and deflect large amounts before it breaks. And then for the thermal transfer, you can simulate how an engine will reach high temperatures and transfer heat to the muffler mount. So Autodesk Nastran brings high-end simulation to all engineers by offering a value-enhanced package. It delivers a single product package as a network license that serves multiple CAD platforms. It's inside your PDM collection. You can also become part of the simulation community. You can find answers, shared expertise, and connect with your peers with the Simulation TV, Resource Center, discussion forums, event listing, learning resources, or ask any questions that you might have. You can go to simhub.autodesk.com for that. We're going to look at a practical example. I have an Inventor assembly. This assembly has a few different parts on it, and we can utilize the parts to look at different features in the simulation programs. We're going to start with one of the arms of the assembly, and I will show you what analysis types are available inside the Inventor environment, and then we will look at how to set up a basic analysis. I've already isolated that arm, and if you want to access some simulation from within Inventor, we can go to the Environments tab. I can choose Stress Analysis. When I choose Stress Analysis and create Study, you can see the Inventor Stress Analysis module contains two different simulation types. Okay, let's look at that again. Something hijacked my computer. Okay, so we're going to look at this arm. I've already isolated it. Right, you can see that it has the two tabs, static analysis and model analysis. And in addition to that, you can also do the shape generator. You can have the program determine what is critical material given the constraints and the load geometry. Potentially remove material from the component that you have. We are going to go into another analysis module or package. If I go into environment, I'm going to select Autodesk Inventor Nastran. The reason we are going to look at Nastran is out of the simulation products that are available, currently this one has probably the greatest breadth of analysis types available. You can see that we are set to a linear static. If you want to change the analysis type, you can just double click, and then from the pull down menu type, you can see there are all different analysis types. Linear static is probably the most common. I have some constraints. I'm going to apply some statically stable load on it, and I would like to know what my deflections and stresses are from that. Then you also have the normal load. If you want to figure out what sort of natural frequencies the structure would produce or react to, you have the buckling module. You have your different vibration modules. There is a fatigue analysis available within Inventor Nastran. You also have heat transfer modules. So if you're going to apply some temperatures to see what the thermal distribution would look like, you would use these modules. You also have explicit dynamic and explicit quasi-static. There's quite a few different analysis types. The linear static one is the one that is most commonly used. So we're going to go and set up to see how to do a basic analysis within Inventor Nastran for linear static stress. Each analysis you do will need some basic components to that. It's generally the material you need to have some constraints in place, loads, and you need to have a mesh. Once you have those fundamental elements to it, you can perform the analysis. We can see that this particular component already has a material associated with it. It is mild steel. If I want to change it, I can right-click and say Edit. I can type in values here in the fields appropriate to my material, or I could select Material and I can utilize the Material Library. We have the Autodesk Material Library and the Inventor Material Library. Or I could load the Nastran Material Library as well. Multiple different ways to get sources of material. I'm going to go ahead and select Material and utilize some material out of the Autodesk Material Library. Let's change it to Steel ASTM A36. There we go. It reads in the values. If I go back into the mini tree here, I can see that it has changed to the new material. You need to have some sort of constraints. You need to have loads and a mesh. So for the constraints, this at the bottom is the end, where the bucket was, and the attachment points to the rest of the assembly. And these two holes here. So I'm going to add my constraints here. In this case, I'm going to say that I need a constraint. I'm going to change from a structural to a pin constraint, zoom in, select the surface that I want, fix radial and axial directions, and say OK. For the moment, we are not going to dive too deep into all the different types. This is just a basic analysis, so you can see what the minimum requirements are in order to perform an analysis. I'm going to do the same with the other point. Pin constraint, fix the directions. Now that I have added constraints to keep the model statically stable, the next I do is to apply some loads. I select the surface, rotate it a bit. Minus Y direction. I'm going to say minus 10,000. We are in metric, so the magnitude is in Newton. We can now generate our mesh. Say generate mesh, and that applies the mesh. I can determine if that mesh is suitable or whether I want to go finer. For the time being, we are going to reduce the mesh size by maybe about half. Okay, generate the mesh, and there we go. There is our finer mesh, and it looks reasonable to me. So now we have the basic minimum requirements. We have the material associated to it. We have the constraints, pin constraints that were added to it. If you need to edit anything, you can just double click and edit the constraints. I have my load. I can double click if I need to edit it. At this point, we are ready to run the simulation. So I'll just go ahead and say run. It's a pretty fast simulation. And then we are in our results environment, and we can have a look at what our results are. By default, it is going to show all the stresses. Again, in terms of the metric unit system. So that is in megapascals. My minimum is about 0 and my maximum is about 15 megapascals. If I want to look at it in a different unit system, let's say the English unit system, I can just go to the drop down and select PSI. So I can see what that is. Maybe I need to submit this to someone who needs it in different units. I can drop down at stress and choose to see what the different displacements are. And again, we are in terms of millimeters here. It's about 0.34 millimeters. This is just a little introduction to what different analysis types are available within the Inventor environment, and we will explore a lot more in the coming months. I would like to thank you for attending today's webinar. I really enjoyed spending some time with you. I am going to open up for some questions. If you have questions, please type it in the questions box that you have on your screen. I see someone said thank you. The presentation was very informative. Thanks for that. I really appreciate it. There's a lot more to come. Simulation is a very wide area, and it will help a lot, especially if you are a manufacturer. And we will be looking into fusion in the future. It's one of the products that we also sell and that we have. And we will drill down a lot more in simulation in the coming months, as I explained, and then also talk a little bit about the data management and simulation in the future. Okay, thanks. Another comment. Someone's working in the manufacturing industry, designing mine machinery, and all presentations that we do covers a lot of what they work with daily. So if you would like to explore any of this a little bit more, I will tell you now how to get into contact with us, and then we can assist you in setting up your software, giving you training, and or just helping you to get more acquainted with all of this software. After this presentation, someone asked if you would get a copy of this presentation. Yes, you will. Maybe by early next week, they will send it out to you, and you will get a link to this presentation. But also remember, on YouTube, you will be able to get any of our previous presentations if you missed something, and even this one will be there as well. Okay, so let's see if there's any other questions. You can pop it there, and we will personally answer them afterwards if I missed any of them. So you might be one of those companies that says you do not have the software to enable you to do simulation. So we sell all the Autodesk products that I've mentioned today, especially Inventor. We can help you to decide what is the best fit for your organization. You may be one of those companies that say you're not sure how to move onwards and or even go back up to 2D to 3D design if you want to start from scratch. We can help you and assess your business and create a tailor-made strategy to get you on your way, to get to all of these different kinds of things, to get to Industry 4.0. And you might be someone that says that your staff is not trained to do this, and we can arrange for training, even on-site and customized to your needs. So we have a iAdopt that we service that we live by. It's assess, educate, and consult. So what is iAdopt? It is our unique consulting methodology that we use to help you as our clients. We help you to develop and implement a digital strategy and transformation. We help you to optimize your business processes and workflows. we help you to adopt your technology, and we help you to design and make a better world. And the benefits of this is that we focus on solving your problems. We deliver tangible outcomes. We address your organizational issues, and we go beyond the CAD environment. And this also includes change management. So as discussed earlier, if you would like to get in touch with us, you can go online and follow us on LinkedIn, Facebook, Twitter, Instagram, or YouTube, whichever one is easiest for you. And you can contact our support desk. It's open from 8 o'clock in the mornings up to 11:30 at night. Telephone number 011 568 2060. And you can email support@bakerbains.com. Any one of us can then get in touch with you. Just pop an email and we will get back to you. But thank you so much. I really did enjoy speaking to you guys. Thanks for the feedback. If you would like to get in touch with us, please contact us. And we solve your problems through digital transformation. We want to help you to design and make a better world. Tune in with us next month and we will talk about simulation a little bit more. Enjoy your day. Bye.